Welcome to Lab 6, Interfacing 4x4 Keypad with Arduino Uno board. In this session, we'll explore the fundamentals of connecting and utilizing a keypad for input in Arduino projects. Our objective is to familiarize ourselves with the hardware components of the Arduino Uno board, understanding its layout and functionalities. We'll use the Arduino software IDE version 1.05 or newer to write, test and run programs that control a 4x4x4 keypad connected to the Arduino Uno. We'll explore the versatility of Arduino by interfacing with different components such as LED, switches, piezo buzzers, and keypad. Here are the materials needed for this lab. Breadboard with Arduino Uno adapter, 220 ohms resistors, LED, piezo buzzers and 4x4 keypad. Introduction. A keypad is a set of buttons arranged in a block or pad which bear digits, symbols or alphabetical letters. Pads mostly containing numbers are called a numeric keypad. The 4x4 matrix keypad usually is used as input in a project. It has 16 keys in total, which means the same input values. It is ultra-thin, easy to interface with any microcontroller, and has an adhesive backing for easy mounting for a variety of applications. Features and specifications. The 4x4 matrix keypad boasts an ultra-thin design with an adhesive backing for easy installation. It offers an excellent price/performance ratio and a seamless interface with any microcontroller. With a maximum rating of 24 VDC and 30 mA, it ensures reliable performance. The interface provides 8-pin access to the 4x4 matrix. Operating temperature ranges from 32 to 122 degrees Fahrenheit or 0 to 50 degrees Celsius. The keypad dimensions measure 2.7 by 3.0 inches or 6.9 by 7.6 centimeters, while the cable dimensions are 0.78 by 3.5 inches or 2.0 by 8.8 centimeters. So how does a keypad work? Matrix keypads use a combination of 4 rows and 4 columns to provide button states to the host device, typically a microcontroller. Underneath each key is a push button, with one end connected to one row and the other end connected to one column. In order for the microcontroller to determine which button is pressed, it first needs to pull each of the 4 columns pins 1 to 4 either low or high one at a time, and then pull the states of the 4 rows pins 5 to 8. Depending on the states of the columns, the microcontroller can tell which button is pressed. For example, say your program pulls all 4 columns low and then pulls the second row high. It then reads the input states of each column and reads pin 3 high. This means that a contact has been made between column 2 and row 2, so button 5 has been pressed. Keypads can be used for various applications, including a password-protected door security system, a wired remote-controlled robot, an electronic voting machine, generating external interrupts, creating a musical keypad, and multiple DIY projects. With its versatility, the possibilities are endless. Here are the procedures. First, connect the Arduino Uno R3 compatible board to your 4x4 keypad as indicated in the given table and graphics below. After the above operations are completed, connect the Arduino board to your computer using the USB cable. The green power LED labeled PWR should go on. Next, open the Arduino IDE and choose the corresponding board type and port type you're using in this lab exercise. Then, write or paste the code provided below and save this as Program 1. Before you can run this, you must import the keypad library, and then once you import it, you can enter it into your program. Once it's entered your program, you should see the line sharp include. If you do not see this, that means that the keypad library has not been successfully put into your code and it won't work. This library is available via the Arduino IDE Library Manager. If you are using a modern IDE 1.6.2 or above, you can simply use the menu. Go to Sketch, then include Library, then Manage Libraries and search for Keypad. Once found, click on its entry and the Install button will appear. A few seconds after the upload finishes, press a key on the keypad. It should show up on the serial monitor of the Arduino software. Now, let's proceed to the lab tasks. Program 2. Arduino Jukebox. Create and design a musical jukebox. A menu-driven system running on serial monitor screen using a keypad comprising 6 preschool rhyme songs or any 6 songs of your choice. With the use of switches, the user can select songs to be played by Arduino. Provide a running light pattern for each song and played as accompanied by the song being played. Program 3. Hexadecimal calculator. Create and design a hexadecimal calculator that can perform the following mathematical operations such as addition, subtraction, multiplication, and division. The mathematical expression formed from typing it via the keypad is being displayed over the serial monitor screen, as well as the output of the said mathematical expression. Program 4. Password-driven piezo buzzer. Design an Arduino circuit for a password-driven running LED. The program will ask the user to enter a password. If the password is correct, it will buzz off the correct musical tone of your choice, and a running LED will light from left towards right. Otherwise, it will display the incorrect running LED pattern of your choice together with a sound off from the buzzer. There is a different tone from the correct password. And then ask again the user to enter the correct password. Provide 3 trials for entering the correct password. At the last attempt, if the password is still incorrect, Arduino will disable the keypad, that is, it will no longer be accepting any entering of password.